Everyone, this is Micah coming to you from over here out of Philadelphia. Hope everyone's having a good morning so far. So what I wanted to do today was just kind of touch on what we've been going over in regards to some algebra, just early levels of algebra, getting us started. So anyways, today I wanted to review the rules for exponents. That's including multiplying, dividing, and then also doing the power rule. So let's get started. So like I said, so the product rule is at the very top. That's when you're gonna have basically any kind of number being taken to a power being multiplied by that same number going to a power, and that's when you see that basically what you want to do is take the exponents and just add them together. So that's the product rule. The second part, the second rule that we're going to be going over today is going to be called the quotient rule. Then you have the power rule, the power of a product rule, power of a fraction rule, zero exponent rule, negative exponent rule, fractional exponent rule. So, I mean, you can obviously see from what's on up there the way the rules work. But what I'm going to do today is actually go through a couple of examples. That way you can kind of, see for yourself how some of these rules work. All right, so I guess what we'll do first is, for starters, we'll start off with the product rule. I have a couple examples already. Just slide them over here. Here we go. Oops. There we go. I guess still want to see my beautiful face. So once I start doing this, I'm going to disappear. But so we'll start with these four problems. The first problem that we have is 3 squared times 3 to the 4th. So what we're going to basically start here doing is, this is really simple. We're just going to add these exponents. So you have 2 and then you have 4. So if we want to go ahead and just bring this over here, we simply would just keep the 3 and then take 2 and then add 4. Because this is going to be based off of the rule. Let's see. Let's see what I had. There you go. So this is just based off of the product rule. And so once you go ahead and add these two, that gives us 3 to the 6th. And then at that point, it's pretty simple. That's just 3 times 3 times 3, and you guys get the point. It's just, we're just multiplying 3 times itself 6 times. Pretty simple. Okay. 1, 2, 3, 4, 5. Then once you do the math there, just get your calculator out, multiply that through, you should get 729. All right, so the next one we're going to be doing 2 cubed times 2 to the 4th. Same thing, pretty straightforward. We're just going to take these exponents and we're just going to be adding these. Okay, so we're adding 3 and we're also adding 4 together. It's 3 plus 4 is 7. So 2 to the 7th. If you multiply that through, you should get 128. Okay, and I'm just going to go ahead and kind of fly through these other two, because I mean, hopefully by now you've kind of got an idea of the way that the process works. 5 to the 6th times 5 to the 11th. We just simply have 11 plus 6, which is 17. That gives us 5 to the 17, which when you go ahead and do the math out, it's actually a pretty crazy number. So I'll write that out real quick. It's actually pretty long. I guess I was just I threw this example in there just to kind of show you that no matter how large the exponent is, it's still the same. The rule's still the same. All you do is just add them together. So it's 4, 5, 3. Yeah, it's some pretty ridiculous number. I just this is one I just came out. I just threw that in there myself. Okay, so, and the last one is 4 squared times 4 cubed. Same thing. 2 plus 3 is 5. So we're just going to get 4 to the 5th power, which is 1024. Okay, all right, so that was the product rule. Now the next thing we're going to be looking at is a rule called the power of a fraction. So let's see. The power of a fraction rule. Go ahead and bring that up on the screen. I'm going to disappear for another second. Okay, so we have, for the first problem, we have 2 over 5 divided by 2 cubed. So it's actually going to work the opposite way of the product rule. So instead of adding the exponents, you're just going to subtract the exponents in this case. So we're going to just bring this down. So you have 2 over 5. And remember, we're dividing that by 2/3. In this instance, basically what we're going to want to do is just keep the 2, but take the exponents. We're going to actually subtract the exponents from each other. So 5 less 3. And 5 minus 3 is 2. Nothing too complicated. So that's 2 squared, which is going to be equal to 4. Kind of like I said, these problems aren't too complicated, so I'm going to go ahead and kind of fly through these other 3 too. Feel free to go back, just pause the video if you kind of missed something, but they're pretty straightforward. It's literally the same exact process. For this one, we're just going to want to take, we have 4 cubed. Well, actually, of course, the second I say that, I get one that's not like that. So let's back up really quick. So in this instance, we're going to have the same exponent on each of the variables that we're working with. So because we have that, we can actually move that exponent to the outside of the fraction, and I'll show you what I mean. So what we can do is put this in parentheses. So we have 4 over 2. That's the initial fraction that we're working with. And what we can do is actually take out the cube and put it outside the parentheses. And since we're doing that, that allows us to go ahead and essentially do what's in the parentheses first, based on the order of operations. So if you remember, it's please excuse my dear Aunt Sally. And so what you want to do at that point, remember, you want to do what's in the parentheses first. So we're going to actually divide 4 by 2 first. 4 divided by 2 is 2. And so then we get 2 cubed. And 2 times 2 is 4. 4 times 2 is 8. So that's our answer. Okay, and I don't think this was actually, this formula was actually on the ones I initially started with, but I want to make sure that if for anyone studying, that you do have the formula. It's a to the n over b to the n is just equal to a over b to the n. And that's essentially what we just did right here. I just pretend that 4 is a and then 2 is b. If you plug all that in, that's how we got to this. Number three, the third example is actually going to be more like the first one. We're going to have 3 to the 6 divided by 3 to the 4th. Basically, pretend we're starting right. We can just start right here. 3 to the 6. Throw some division in there. 3 to the 4th. Okay. 6 minus 4 is 2. So that turns into 3 squared. 3 times 3 is 9. Super simple. Same thing for this one. 6 to the 10th power divided by 6 to the 7th power. Simply just turns into 6 cubed because we are subtracting 7 from 10. And 6 times 6 times 6 is equal to 216. Okay, so that's it for the power of a fraction rule. The next rule I wanted to cover in this video, let's see, I want to do the negative exponents rule. Just slide this over here. Okay. Exactly. Okay, that's good enough. All right. So the first example we have is x taken to the negative 4th. What does that equal to? All right. So what you want to do in this case is basically first pretend that the 1 is a fraction. So I know when I say that, you're going to be like, well, Micah, there's no 1. Like, what are you talking about? All right. So anytime that you do see a fraction by its a variable and up to a exponent, there's always a 1 right here. So I mean, no matter whether you can see it, you can always assume that a 1 is part of the equation, just that the 1 doesn't impact the equation. And I'll show you exactly what I mean. So let's just say that we have 1 times x to the negative 4th. What does that equal? Well, that's just going to be the same thing. It's just going to be x to the negative 4th. So essentially, it's like the 1 is almost there, but it's not there. It's like, even if we put the 1 in the equation and we show it and we represent it actually and physically, it's not even there. I mean, it has no impact on the equation. So that's what we're doing in this instance. So what we want to do right here, and I'll just back up a little bit, is, oops, I think I went back a little bit too much. Basically, what we want to do, I'll just put that right back, is pretend the ones there, like actually represent the 1. So 1 over 1 is equal to 1. You guys with me so far? So that's the first thing we need to make sure we know. So 1 over 1 is the same thing as 1. I want to make sure I don't go back too far this time. All right, so now that we know that 1 over 1 is equal to 1, we can take that and plug that into this equation, and that's going to help us. So 1 over 1, and then we take that times x to the negative 4th. That allows us to do this. Say that 1 times x to the negative 4th divided by 1 is equivalent to the inverse of that. Now I know that's kind of tricky, but hear me out. So what we essentially did was take the number 1, multiplied it times our initial equation, and we didn't change it at all because this is where we are. So like I said, remember 1 is here the whole time. Just pretend it's there the whole time. Actually, it is. It's always been there. We just didn't represent it. Now all we're doing over here is actually showing that 1 is part of the equation, and then on top of that, we're going to invert the equation. So now that we have 1 represented, we're going to go ahead and flip the equation. Remember, when you take the inverse, you just take what's in the denominator, but goes to the numerator, and what's in the numerator goes to the denominator. So in this case, we're going to have 1 over 1 x to the 4th. But, and keep in mind, one of the primary reasons that we did this was to get rid of this. We wanted to get rid of the negative. So whenever you invert a fraction, anything that is in the top of the fraction or in the numerator, once it moves to the denominator, you lose the negative, let's say. So it turns positive. And I can make a video later on about that, but right now you're just gonna have to trust me and believe that, you know, that's one of the rules. It's a basic rule, but like I said, I'll do another video later to go more in depth about that rule. So for right now, we have 1 over 1 times x to the 4th, and basically what that's going to leave us with, like I said, the same thing as if we did it right here. It's going to be 1 over x to the 4th. And keep in mind that 1 is still here. We're just not representing it in the answer. So this is the answer. It's just that we're just going to go ahead and write it. We're just going to drop that 1. Okay? Like I said, going to go back over, and the one thing about this problem that, like I said, I haven't covered yet is inverting anything with the negative and the exponent, and then showing that it goes positive, like I said, from right here to right here. That's probably the most important takeaway about this problem. But like I said, I'll make another video later on, and I'll further explain that. Okay, so the next one is x squared divided by x to the negative 3. So what we want to do in this equation is also get rid of that negative that's in the bottom. So we have this negative 3 that's in the denominator. We want to get rid of that. So same thing as last time. We're just going to take everything and do the same thing. We're just going to incorporate 1 over 1 into the equation. So in this case, we're going to have x squared and then we're going to have that being multiplied by 1, 3. Same thing. We're going to flip that. I don't really want this to get. Here, let's do this. That way you can see that this is for this equation. Probably should have spaced these farther apart, but it's all good. Okay, so once you go ahead and do the same exact thing, you invert that, x squared Actually, hold on, sorry. Wait, I did this one wrong. That's why I paused for a second. Okay. No. We're actually supposed to have x, here we go. X squared x cubed over 1. There we go. So get that line again. There we go. And so what we're going to be doing here is, oops, splitting it apart. So what we did was, okay, so you had x squared actually, hold on. Let me just keep going until I go back. Okay, so just for the sake of time, it's gonna be, you do the same thing. You take this and we invert that. We're gonna invert this. Thank you. That's what it is. Yeah, so we invert this, bring this into the numerator, and then that's how we have the 1. So when you invert, I'll put it over here. So when you invert x to the negative 3, you get x cubed over 1. And so that's what we did right here. So we took x cubed over 1 times, times x squared. And that, this gave us that, and that is what gave us that. Yeah, sorry about that. Now let's get that out of the way. And then at that point, it's pretty simple. If you divide by 1, the 1 goes away. Using our rules for multiplication, or the product rule, we know that x squared times x cubed is going to be the same thing as if we just added these together. So it's going to be x to the 5th. All right. Same thing for this one, almost. You have 2 times x to the negative 1 is equal to some number. What we're going to want to do is, I'm just going to, you know what, I'm just going to leave that alone. We have 2, it's just that everything's getting kind of bottled up here. I guess. Yeah, there we go. There we go. Okay. All right, so 2x to the negative 1. We're going to take that and put that over the 1. Remember, in this instance, when we do that, we're just taking 1 times the equation that's already there. So essentially this becomes 1 times 2x to the negative 1 over 1, but we're just not representing this one, okay? So I just don't want you guys to get confused when I do this, because after a while I'm going to start doing it faster and faster, and I'm not necessarily going to stop and explain every time I do it, because it's just going to slow us down too much. We won't be able to get as much done. So like I said, go ahead and multiply it times 1, and then having 1 in this point denominator, that gives us the flexibility to go ahead and invert the fraction. So what we can do is, at this point, take the negative and put that in, the x to the negative 1, and put that into the denominator. So we'll have 2 over 1 to the x. But remember, so this turns positive. So it's just x to the 1. That means we just have 2 over x. Because 1 times x to the 1 is just x. Okay? And then for the last one, let's see, we had, we had 3x to the negative 2 is equal to some equation. So what we want to do right here, same thing, we have 1 times the initial equation, 3x to the negative 2 over 1. And when we go ahead and invert that, we are going to get 1 over 3x squared and then what we can do is at that point we want to break it apart. We can break apart the denominator. So once we do that, we're going to get 1 over 3 squared times x squared. And keep in mind, all we're doing is just taking that 2 and we're just distributing it to the 1 and to the x. Okay? And then once you get that, it's pretty simple. Just get 1 over 9 x squared. Okay, so I know I kind of threw a lot at you guys in this video. Hopefully you guys were able to grasp all the stuff I was going over in this video. Hopefully you guys kind of like my little background using the photo booth to kind of get that. So anyways, I'm going to go ahead and call it a wrap for this video. The next video, what I'll do is go ahead and start going over some more rules, but I think the next video, because I'm running out of time, I'm going to probably just do some examples that incorporate all the rules. Like have the product rule, the quotient rule, the power rule. Like I said, just do a bunch of them. So anyways, if you guys liked what you guys saw, please subscribe. And also, I do offer tutoring online. I tutor in economics, statistics, and everything else is listed on my profile. That's going to be in the link in the description below. All right. Thank you guys and have a great day. Bye.